Welcome to VKS Coding. In this video, we'll talk about system design for rate limiter. So this will be the high level design and we'll understand each and every thing about rate limiter. So let's first understand what is rate limiter. So suppose we have a client here and we have a server here. And when the client send a request to the server, so client can send many end requests to the servers like R1, R2, R3, R4. So there is no limit here to be specified how many requests from the client to the server to be sent. So the rate limiter limits the number of the client request allowed to send over a specified period. It means we can set a rule something like that in 1 minute only 5 requests can go from client to server. So in middle we can put something kind of a rate limiter here. So which will filter only in 1 minute. It will check if the 5 requests are there, it will allow, and if the sixth requests are coming, then it will drop it. It will not send that request to the server. So this is the rate limiter in the basic idea about the rate limiter, how it is. So client send a request to the server and in between rate limiter will be there, and on top of the rate limiter some rule will be defined like in 1 minute how many requests can be processed to the API server, and this rule can be dynamic and this can be changed as per the requirement, and this is the basic idea behind the rate limiter. So let's move ahead and see what are the benefits if we add a rate limiter. So first benefit will be is it will preserve the resource from the starvation caused by the denial of service attack. What I meant here is suppose any bot or something, there is a API server, and in the API server continuously somebody is requesting like R1, R2, R3. Many requests are coming to this server, and this will if the many requests are coming to this server and if the server is not able to handle those requests, the server will go down. So this can happen via the bots, means some bot application and something, and for that we call as a DDoS attack. DOS attack also we call denial of service attack. So how to prevent that? If you put a rate limiter in front of the API server, so it will block the access calls. So it means only limited number of requests will go to the API server. So this is the first benefit, like it will preserve from resources from dot denial of service attack. And the second benefit will be it will reduce the cost. So how it will reduce the cost? Limiting the access request means we have a few servers, means only few requests are coming, then it means we don't need many servers to handle these many requests because we put a rate limiter here. Okay, and this rate limiter will filter it out only the specified route, like 5 requests can come, and this 5 requests will be served by like 2 year, 3 year. So we don't need many servers here. So with that we can reduce the cost of a server as well. And third benefit also we get like a preserve server from being overloaded. So prevent server from being overloaded. What I meant here is, suppose many requests are R1 is U1 is sending a R1 request and U2 is kind of a bot and it is sending a many request like R2, R3, R4, R5. Then here in the rate limiter we can filter it out like based on the user, only 5 requests can be allowed or 3 requests can be allowed. So with the help of that we can prevent the server from being the overloaded. So this is the way we'll get many benefits of putting a rate limiter in front of the API server or in the API server. So we'll discuss all these things about it. So this is the basic idea behind what is the rate limiter and the benefits of the rate limiter. So let's move forward and collect some requirements like how to design a rate limiter and all. So what will be our first question to the interviewer is what kind of a rate limiter are we going to design? Is it a client side rate limiter or it's a server side rate limiter? So I think it will be a great question for interviewer as well. So he can say you we can focus on the server side API rate limiter. So he can say is like server side API rate limiter. And again, the second question will be that does rate limiter throttle the API request based on the IP or the user ID or the other properties, like how we gonna throttle it, right? So for that, if the interviewer will say flexible enough to support different set of rules, because we cannot restrict on the based on some only one parameter, right? So we need to build it like flexible to support multiple rules. Now the third question will be what is the scale of the system? It is a build for a startup or it's a bigger company with the larger user base. So interviewer can say system should be handle the large number of requests. Means it will be not based on the startup or the largest company. It's a based on the request. So it can handle larger request. It can handle larger request. And the next question will be, will the system will work in the distributed environment? So yes, interviewer will say yes, it should work because all the system design interview question are related to only the distributed system only. Yes, it should work for distributed systems. And one more question we can ask is it a rate limiter is a separate server or should be implemented in an application code itself? So interviewer can say decision is up to you. I mean design decision is up to you. Up to you. Up to us. So we can explore like where to put the rate limiter, client side, server side, middleware, or in the API gateway. So there are different mechanisms to put that. So we'll discuss in detail about this. And we can ask one more question is do we need to inform the user who are throttled? It means if the requests are getting declined for a particular user, should we notify the user? Yes, we need to notify the user for for decline request. So these are the six actually parameter we need to consider while designing the rate limiter. First one is we need a server side API rate limiter, and second one is it's flexible enough to support multiple kind of rules on it, and it can handle for a large request, and it should work with the distributed environment. And design decision is like where to put the rate limiter based on our decision. And the next one will be we need to notify the user when their request is getting throttled, means when we start declining the request. So let's see next try to explore. So where to put exactly the rate limiter. So in the first diagram I have represented here the client side implementation. In the client side implementation, what will happen in the client, rate limiter will be there, and from the client rate limiter the request will be filtered and the HTTP request will be sent to the API server. But the problem here is the client is an unreliable place to enforce the rate limiter because the client request can easily manipulated by malicious actors, and we might not have a control over the client side implementation. So that is the reason we are not going with this client side implementation. Let's check on the server side implementation. In the server side implementation, the client will be there, and in the API server itself the rates limiter will be running inside it, and HTTP request will go to the API server, and within that it will rate limiter will filter the request. And third kind of rate limiter will be in the middleware rate limiter, where the client is a separate entity and API server is a separate entity. In middle, we have a rate limiter. So request will first go to the this middleware, rate limiter middleware, and then it request will be transferred to the API server. So these are the three types of a rate limiter can be possible while designing for a rate limiter. So so we'll discuss which one we gonna use it. Either we are proceeding with the middleware or the client side implementation or server side implementation, because client side we cannot use it. I told you about the reason, because the client side request can be easily manipulated by the malicious actor. So let's see how actually basically the rate limiter works. Then we'll move further and we'll try to design the rate limiter. So let's see first how rate limiter works. So suppose we have a client here is either a mobile device or a desktop or a server or a system, anything, right? So first the client send a request, like R1 request is sent to the rate limiter. Then rate limiter will be transfer this request to the API server. And suppose some rule is specified, and the rule is two requests per second. Two requests per second. So suppose the timing will be here is 10.00.01. So this is the 00, and the first request came at this time, and the second request is coming at 10.00.0.5. So at this time second request is coming. So second request will also go through. This is a R1 will go through, R2 will also go through, and suppose third request is coming, and this is also in the same 1 second window, but it will be dropped. That request will not be transferred, and this request will be dropped, and it will return HTTP status code. We can return 429 too many requests. So this is the basic function of how the rate limiter will work. And here we have specified the rule, two requests per second. So in 1 second time frame, we are checking how many requests are coming. So here, if you see, we have sent three requests, R1, R2, R3. First request came at 10.0.0, so it is processed. Second request came at 10.00.05, so second request is also processed. And third request came at 10.00.1.0. It means within a 1 second time frame, all three requests came. So two are processed and one are declined. And so this is how the rate limiter works. And nowadays, the cloud microservices have become a widely popular, and the rate limiting is usually implemented within the component called API gateway. And while designing the rate limiter, it's a very important question to ask ourselves where we should put a rate limiter while implementing. Either we should go with the server side in a gateway, or they. So basically there is a no absolute answer. It depend upon the how the company tech stack is, their engineering resources. So according to that, either we can go ahead with the middleware rate limiter or the API side rate limiter. So let's move forward and try to understand how what are the different kind of algorithms we can use to build the build a rate limiter. So we'll discuss five algorithm for a rate limiter. First one is a token bucket. Second one is a leaky bucket. Third one is a fixed window counter. Fourth one is the sliding window log, and the fifth one is the sliding window counter. So all five we'll discuss one by one, and we'll also discuss the detailed design and how it will work in the distributed environment, this rate limiter. So please keep watching this video. You will get to know all the details. So first one will be the token bucket. So here in the token bucket, the name itself implies here the bucket will be used. So here the bucket is there, and the bucket capacity is a 4 token, and here is a refiller. And the refiller work is it continuously fill the token into the bucket, and here the rule is a rule is specified for the refiller here, 2 token every per second. It means at 10.0.0.00, so it will fill 2 token, and again at 10.00.1 again it will fill 2 tokens, so like that. And if the bucket capacity is full, if the if the bucket is already having the full token and the refiller tries to put the more token, then the other token will be dropped. So this is how the overflow token is happening here. And the if the capacity is there in the bucket, it will be put into the bucket. So how actually it will be work? So this is the token bucket. So this is how the token bucket is getting filled with the token and having the capacity, and how the token is getting overflowed. So let's see one example how actually when the request will come and how the token will consumed, and how the things works in actual environment. So let's see the example. So here we have an example. Let's see first instance here. So suppose we have a 4 token. So here we have defined the rule here, a 4 token per minute, and the bucket size is also a 4. So this is a kind of a bucket, and initially it is having a 4 token and the time is 1.0.0. So first request came here and one token is consumed here. So it means only one token is consumed by one request. So only 3 tokens will be left for another request. In the second instance, if you come, 3 requests are coming here and 3 tokens are also left. So it means R2, R3 and R4 all will be processed and the time will be 1.0.05. It means within a same minute, uh, 3 tokens are consumed. Previously, we have one token consumed, and the in the same minute, we have 3 more request came. So all three remaining tokens are also consumed. So it means we are no tokens left for another request in the same time frame, same minute. So if you see here, another request came. So R5, another request came here is the 1.0.0 at 20th second. So here the request will be dropped. So because there is no token left here, and in another minute, like it is the zeroth time, right? 1.0.1. So this time again 4 token will be filled. So refiller will fill again 4 token here. So this is how the token bucket algorithm will work. So what is the advantage and disadvantages? So we'll see, but we'll see one more detailed diagram of this token bucket. Means we'll see one flow chart and then we'll discuss the pros and cons of this token bucket. So token bucket, yes. So here if you see, in the top it is a refiller. So it will continuously fill the token as per the rule, and when the request will come from the client. So from the client, requests are coming, and here first it will check it is having enough token. If it is having enough token, it will consume one token. It will pass to the API server and it will consume one token. And when the request comes and if there are no token left in the bucket, then the request will be dropped and the refiller will fill the token into bucket as per the rule, right? As per the rule, refiller will fill the token. So what is the pros and cons for this token bucket algorithm? So it kind of easy to implement and memory efficient as well. But what is the drawback here? The drawback here is 2 parameters in the algorithm are the bucket size. So first one is this is the bucket size here and the token refiller rate. So this one is also. So it might be difficult to fine tune them. So we'll not to be able to means properly set these 2 parameters because these 2 parameters are independent and we have to make it correlated to work in a better way. So let's see the another rate limiter algorithm. So another one is leaking bucket algorithm. So what is a leaky bucket algorithm? So this is also very simple. Suppose there is a one bucket and it is having some size. Suppose size is 4 or 5. Suppose size is 4 and the requests are coming. If the requests are more than the bucket size, then it will be dropped. So if you see here, R5 is dropped and its capacity is only 4 and the requests are processed in the constant rate, like at 1 minute only one request can be processed, like that. So here also, but the difference here is it will process as a constant rate, and if the bucket size is filled, then the requests are dropped immediately. So this is the basic one. Let's see one flow chart to understand better here. Yes, so if you see here, The leaky bucket algorithm is similar to the token bucket, except the requests are processed at the fixed rate. And Shopify e-commerce company also uses the leaky bucket algorithm. And here, suppose the client sent a request here, then it will first check the bucket is full or not. If the bucket is not full, that it will put the request in the queue. And in the fixed rate, like three requests can be processed at a time. So here the three requests will be processed by API server. And once the this queue is full, so here the bucket size equal to queue size in the leaky bucket algorithm. So if the bucket is full, it means there is no place in the queue to put the request at that time. It will be the request will be dropped. So here, if the R5, if the next request R6 will come, then R6 will be dropped because the queue is full. So this is the basic idea behind the leaky bucket algorithm, and we can easily implement with the help of queue. Whenever the request will come, we'll put into the queue, and once the queue is full, we start dropping the request. And from the queue, it will be the API server can be processed at the constant rate. Some requests like three requests at a time, and in the next batch again it will take three requests at a time. So like that it will be getting processed, and the request will be served. So what is the pros and cons for this algorithm? So memory is efficient because given the limited size of a queue, requests are processed at the fixed rate. Therefore, it is a suitable for the use case. That is a stable outflow rate is needed. Means stable output flow means at constant rate, request can be processed, right? Output flow rate. And the cons, it is at the burst traffic will fill up the queue, and which will hold the old request, and if they are not processed in time, the recess request will be the rate limited. And so what I meant here is, suppose this processing is taking time. Suppose R1, R2, R3 processing, it's taking time, and here another requests are waiting like R4, R5, R6, R7, R8, R9 are waiting in the queue. But if the latest requests are coming R10, it will be request will be dropped because these are not processed yet and queue are full. Right, so that is kind of also a drawback in the when the traffic is burst, right? Many requests are coming. That time this can't be the issue. So let's check the another algorithm. So the next algorithm will be the fixed window counter. So let's check what is that. So fixed window counter is very simple. Suppose we have defined a rule like in 1 second three request, 1 second three request. Right, so suppose R1 is coming here, R2 is coming here, and R3 is coming here, and all three will be processed. But if suppose here it's coming R1, R2, R3, then all three will be processed. But if the another request will come like R4, R5, then this request will not be processed because we have defined only three requests per second. So this is the basic idea behind the fixed window counter log, and how it will work is like initially the counter will be zero, and when the first request will come, the counter will be incremented to 1. When the second request will come, counter will be incremented to 2. When the third request will come, the counter will be incremented to 3. And when the fourth request will come, so it will check it is in the maximum, 3 is allowed, so it will start dropping the request. So so the algorithm divides the timeline into the fixed size of a time window and assign the counter for each of the window like 3, 3, 3, 3, and each request increment the counter one by one, like I have shown the example here. Once the counter reaches to the predefined threshold, new request will be dropped until the new time frame window starts. So in each time frame, we will get the 3 tokens to process the request. But within the same second, if we getting more than three requests, then don't more than three requests will be dropped. And while processing the request, every time the request is getting Coming to the rate limiter, the counter will be incremented, and it will check the maximum allowed values. There is a problem with the fixed window counter as well. So let's check the what is the problem here. But I think we understood right how fixed window counter is working. So the algorithm divides this one, the timeline, into the fixed size of a time. This one, like this is the 1 second, 1 second times are there, right? And each second is having the particular counter here defined. And whenever the request come, the counter will be incremented, and like that, if it is reaches to the maximum defined value, after that the request will be start dropping. So let's check what is the issue with the fixed window counter. So suppose here the request, the rule can be five request rule will be 5 requests per second. So here I have defined a 5001, 5002, 5003. So there will be a scenario. What will happen at the edge of the, suppose this is the time series is going on. This is the time series is currently running, and in the edge the requests are coming R1, R2, R3, R4, R5, and here it came R6, R7, R8, R9, R10. So if you see here, in a 1 second, we have a 10 request. So this is a kind of a drawback of using the fixed window counter, because at the edge, if we get the request and we are not able to process, then within a second, the request can be double. So the major problem with the algorithm is that the burst traffic at the edge of the time window could cause the more requests than the allowed quota to go through. So this is the problem with this algorithm. Got in the fixed window counter. So let's check the another algorithm which will fix this issue. So another algorithm is the sliding window log. So the next algorithm is the sliding window log, and the sliding window log fix the issue more request coming to the edge, and the algorithm keep track the request timestamp, and the timestamp data is usually kept into the cache. So this is the kind of a cache. Suppose the first request came at 10.0.0.1. So first it kept into the log, and the request is processed. And the rule is 2 requests per minute. In the second diagram, if you see here, so the request is coming 10.0.0.30. Then here it's like within a same minute. So then second request will be also processed. The third request are coming at 10.0.0.50. It is a kind of same minute, but the requests are only allowed 2 requests. So it will timestamp will be logged into the cache, but the request will not be processed. And at the in the next new minute, right? So when the 10.0.1.40, that time what will happen when the new request is coming in the when the new request comes in, remove all the outdated timestamp, and outdated timestamp are the defined of those older than the start of the current timestamp window. So what I meant here is when the new request came, so before this one, like 10.01.40 to 10.00240, between this time, before this time, so this is the current minute, right? This is the current minute, 142.0040. Before that, we have to remove the entry from the cache, right? And the remaining will be there, but the request will be recent request will be processed. Like there is this request is a 10.0.1.40. It came and it is processed. So the drawback here is, so what is the pros and cons for this one? So rate limiter implemented by this algorithm is very accurate, and in any rolling window request will not exceed the rate limit, because we are keeping the timestamp properly and then we are processing it. So what will the problem here? The algorithm consume a lot of memory, because even the request is rejected, the timestamp might still stored in the memory, right? In the case of here, the request is means not processed, but it is what's in the memory, right? So that could be the issue. So let's see the next algorithm, how that will fix this issue now. So the next algorithm is a sliding window counter, and the sliding window counter algorithm is a hybrid approach that combines the fixed window counter and the sliding window log, and let's see how it is solves the problem here. So first, we will define the rule. Rule is a 7 request per minute, and here we have defined the time frame. So assume the rate limiter allows the maximum 7 requests per minute, and there are 5 requests in the previous minute. So this is the R1, R2, R3, R4, R5, and this is a kind of a previous minute, and the 3 requests are in current minute. So this is the current minute which is going on, right? So this is the current minute, and these are the 3 requests are going on. So for the new request that arrive, so for the new request which is R9, right? So for new request which is coming at R9 here. So first, let's track it. So this is a kind of 70%, and this is a kind of 30% time frame, like in a minute. So this is a kind of 1 minute. And suppose one new request is coming here. So this is allowed or not, we have to calculate it. So how we gonna calculate is the number of requests in the ruling window is calculated by the below formula. So the current request in the window is kind of 3 or 1, 2, 3 plus the request in the previous window are 5 into overlapping percentage of the rolling window and the previous window. It means the overlapping percentage is the 70 divided by 100. So if we divide it, so it will come, this will value will come 0.7, and it will altogether come 6.5. So it will close to 6, and we have a maximum is kind of a 7 request. So when the IR9 request will come, it can be processed in this rolling window. So this is the how we can calculate the rolling window, whether the request is allowed in the particular time frame or not. And since the rate limiter allows the 7 requests per minute, the current request will go through. So this is the uh, sliding window counter works. So let's check further. So this is all about the 5 algorithms. So now let's proceed further and check the high level diagram of the rate limiter. So basic idea of a rate limiter algorithm is simple. At high level, we need to count the keep track of how many requests are sent from the same user or the IP address etc. If the counter is larger than the limit, then request is disallowed, right? And where shall we store the counter? That is also a question. Uh, Using the database is not a good idea due to the slowness of the disk access. In-memory cache will be chosen because it is a fast and support the time-based expiration strategy. So Redis will be popular choice, right? So store the counter. So rate limiter. So here you see the example. So rate limiter middleware fetches the counter. So it will fetch the counter. So rate limiter middleware fetches the counter from the corresponding bucket in Redis and check if the limit is reached or not. If the limit is reached, the request is rejected. It means suppose R1, R2, R3 are coming, and suppose in 1 minute two requests are only allowed, then R1 and R2 will be processed by API server, and R2, R3 will be dropped, or the status code will return to 429. It's kind of too many requests. So first rate limiter fetches the counter and the corresponding bucket from the Redis cache, and it will check the limit exceeded or not. If it is not exceeded, it will pass the request to the API server. Otherwise, the request will be dropped. So this is the high level diagram of the rate limiter, and suppose exceeding the rate limiter, in that case the request are rate limited. So how we gonna notify the user? So this HTTP status, right? HTTP status 429 status code will indicate there are too many requests to the client. So this 420 status code indicate there are too many requests. So this is the high level diagram for the rate limiter. So let's see one detailed diagram about the rate limiter. So this is the detailed diagram of the rate limiter. So let's first understand the each component. So rule are stored on the disk. So here our rules are stored in the disk here. So these are the in the disk, and the workflow. This is the workers frequently pull the rules from the disk, and it will store into the cache. So here it will store into the cache, and when the client send the request to the server, when the client this client send the request to the API server, then the request is sent to the rate limiter. This is the middleware first, and the rate limiter loads the rule from the cache, and it fetches the counter and the last request timestamp from this Redis cache. And based on the response of the rate limiter decides, this here the rate limiter decide if the request if the requests are not limited, then it's forwarded to the API server. It means success. It will forward to the API server. And if the request is rate limited, then it can return the HTTP. If the request is rate limited, then it can return the 429 status code, HTTP status code. Or they have a different, or we can have an option either to drop the request, or we have another option to put in the message queue to further processing. So basic idea here is the rules are defined and stored into the cache, into the disk, and the workers are running in the background, which will fetches the rule from the disk and put it into cache. And when the requests are coming from the client, it will go to the first to the rate limiter, and rate limiter will fetches the rule from the cache and the counter from Redis cache, and it will compute the algorithm and decide the requests are rate limited or not. If the requests are not rate limited, then it will pass it to the API server, and the request is rate limited, then it have multiple option based on the implementation. One implementation can be it will return the HTTP status code 429 indicating too many requests, or the other option it can drop the request. Another option will be put into the message queue for the later processing. So this is all about the detailed design of a rate limiter. So I hope I made a clear understanding about the system design of a rate limiter, but still we have a few things to discuss, like how the rate limiter behaves in the distributed environment and what will be the problem. So let's discuss further on it. So building a rate limiter that works in a single server, it's not very difficult, right? But scaling in system to support the multiple server and concurrent thread is a different story. So there will be a two challenges. So when the rate limiter we implement in the distributed environment, so first will be the race condition. Race condition. It means two thread like T1 and T2 try to access same counter at a time. So how we gonna handle it? And the second one is the synchronization issue. How the synchronization issue? Suppose we have a rate limiter R1, rate limiter R2, and here is a client C1. So it will send a first request to R1 rate limiter, and the second request it will send R2, and then again it send the third request to this server and fourth request to this server. How this rate limiter each other get to know the same client is sending the request? So we have to make the synchronize between these rate limiter. So these two scenario we need to handle in a distributed environment. So let's discuss one by one how we gonna solve it, and let's discuss problem in the detail. So first one is a race condition. So suppose first request is coming and it's read the counter as 3, and it will check and try to increment as a 4, and the second request also coming concurrently, and it will also read the same counter value as 3 and try to update the concurrently 4, but the actual updation could be 5, because 4 is implemented incremented, 3 is incremented by the request 1, and then request 2 should increment 4 to 5. But due to concurrency, before a update of request 1, the request 2 also read the counter and try to update. So this is a kind of a race condition. So How we gonna fix it? This is very simple. We can put it into the lock. You know how to work with the lock. We can lock it, put the counter here, so only one thread can come here, and which acquire the lock, increment the counter, and then we put unlock, and again second thread will come. So this is the way how we can resolve the race condition. So this is the way how we have to resolve the first issue. Now let's go with the another issue. So second one is the synchronization issue, and this is also important factor to consider in the distributed environment. To support the million of a user, one rate limiter server is not enough to handle the traffic. When the multiple rate limiter servers are used, synchronization is required between these two rate limiter, right? Suppose a client one sent a request to the rate limiter one, and client two send a request to the rate limiter two, and also the web tier is stateless, means these are stateless, then the client can send a request to a different rate limiter as well. So here client 1 can send to rate limiter 2, and this client 2 can also send a request to rate limiter 1. So in this way there is no synchronization happen with the rate limiter 1 does not contain any data about the client 2. So in this way, this will be a problem in the synchronization between these rate limiter. So how we gonna fix it? Because otherwise we will not be able to rate limit, right, for different clients if the requests are coming, if requests are going to the different rate limiter. So I hope I'm able to make you clear about what is the issue, right? So how we gonna fix the issue? So one possible solution is the we can use the sticky session that will allow the client to tend to send the traffic to the same server if you put the sticky session, right? But this solution is not advisable because it's neither be scalable and flexible. A better approach will be if you push the centralized Redis cache will be the better approach. So this approach will be better if you put the centralized. If you put the centralized Redis cache, if the client one send the request to the rate limiter one, then it will read the counter value from the centralized Redis, and it will update the value accordingly and allow a rate limiter. And similar, the client to also send the request to either a rate limiter 2 or rate limiter 1. The value will be fetched to the centralized Redis, and it will decide based on that either we request are rate limited or not. So like this, if the requests are going to the rate limiter 1 or rate limiter 2, it doesn't matter. Centralized Redis will solve the problem. So this is all about the high level and all the concept related to the rate limiter system design. So I hope I am able to make you clear. So thank you for watching the video. Please subscribe my channel for getting the best resources on the system design and low level design.